Hi, everyone. My name is Amirhossein Jafarzadeh Ghazi, and I am a PhD student at Ontario Tech University, and I'm working with Dr. Salma Karray and Nader Azad. Both of them are from Faculty of Business and IT and at Ontario Tech. And today I'm going to be presenting my work, which is actually the first part of my PhD research on pricing and quality decisions when there is a risk of a product recall. This is the outline of this presentation. So I'm gonna start with a brief introduction, and then I'll move on to the literature review. And later on, I will mostly focus on the details of the model. And finally, I will review some important or main results and outcomes of this work. So to start, I'd like to present some real-world examples, two real-world examples of product recalls to have a better understanding of the concept of this work. So these days, the number and significance of product recalls have been substantially increasing, and this is in various industries like the electronics industry, food, pharmaceutical, and so on. The first example is about the electronics industry, and it is for Galaxy Note 7's recall. So in 2016, 2.5 million Note 7s were recalled due to overheating and exploding batteries shortly after its launch. And this led to a loss of $5.3 billion for the company and 8% drop in the company's stock price. And finally, Galaxy Note 7 was removed from the market forever. On the other side, the main competitor of Galaxy Note 7, that was iPhone 7, had the opportunity to capture lost consumers from after Note 7's death and lead the smartphones market. In another example, in the food industry, so Kraft peanut butter in 1996. So Kraft Australia recalled its top brand in the category, in the peanut butter category, Kraft and Ita, and the reason was risk of salmonella contamination. Also, this recall resulted in 540 lawsuits for Kraft, and both brands were taken off the shelves and they were removed from the market. And at that time, Sanitarium, the main competitor of Kraft peanut butter, invest in TV and newspaper advertisements to announce that its peanut butter was not contaminated. So, and also they increased its price by 8% to boost the revenue of the company. So these examples and many other examples of product recall show us how a major product recall can impact the financial viability and also brand equity of the firms. Speaking of competitors in the market, like iPhone 7 for Galaxy Note 7 and Sanitarium for Kraft peanut butter. Also, the literature suggests that there is a spillover impact of product recall on the other products in the same category. So there are many studies that suggest a recall can impact the quality or price sensitivity of consumers. For example, consumers after recall, they could put more weight on quality or less weight on price. So they can be more quality sensitive or price sensitive or vice versa. And therefore, it is important that competitors in the same category make post-recall price adjustments to moderate the negative impact of a recall, or even to capture lost consumers from the affected firm. So these are suggested by the literature. But now when we take a closer look at the literature, so the existing literature investigates various themes in product recall management, such as pricing decisions, quality decisions, pre or post-recall advertising, even a stock market reaction to a recall or recall timing. Also, the literature suggests that quality-related product failures are often found to be the main reason, the main culprit of product recall. However, most studies consider that the probability of recall is an exogenous parameter. So it means that firms actually are not able to control their recall occurrence, but we know that firms can control their recall occurrence by investing in quality of their products. So based on our survey of the literature, so there is a lack of research in modeling both price and quality, where the probability of recall is endogenous. And in a few minutes, you can see that we define probability of recall as a function of quality. So it means that firms can control the recall occurrence by investing more in quality. So now I think you have a better idea of what kind of product recalls we are talking about here, and also what kinds of competition I'm discussing here. So let's dive into the model in the interest of time. So, so to investigate the research problem and fill the gap in the literature, we built a game theoretical Nash game. We assume these are the model assumptions. So first of all, we assume that two competing firms, I and J, selling differentiated products in the same category, and they compete in price and quality, P and Q. And each firm faces the risk of a product recall due to quality issues. So both firms can have recall, even at the same time. And also, the third assumption is that when a product is recalled, as we see in the major product recall example, so this product will be removed from the market, at least for a short-term period. It could be 4 months or even forever, like Galaxy Note 7 example. And finally, to consider the impact of, in fact, the spillover impact of product recall on the product category and other brands in the same category, we assume that a product recall can impact quality or price sensitivity of consumers in the category after recall. So we have this game sequence here. So this is a two-stage Nash game. And in the first stage of the game, both firms decide on quality of their products simultaneously, and they make decision about their quality of their products, Q. And based on, depending actually on these chosen qualities. So there are three possible scenarios. The first scenario, scenario NR, in the first scenario, so no recall happens. So in this scenario, in a stage 2 of the game, both firms are in the market and they are competing in price and quality. But before that, they make decision about prices of their products. And this is a competitive market, so the prices are competitive pricing strategies. So in the second scenario, scenario R, here you can see that product recall occurs only for one firm. And this affected firm, as we had in the model assumption, so this affected firm will be removed from the market and only one firm remains in the market, which is the competitor of the affected firm, right? And this firm is actually in the remaining firm is in a monopolistic market. So this firm can set a monopoly price here, right? And finally, in the last scenario, which is also a possible scenario, both firms can have recall. So both of them will be removed from the market and no one is in the market. And these are the only possible scenarios mathematically also. So to solve and analyze this model, first of all, and actually using backward induction method. So we start from stage 2 of the game and going backward to stage 1. In a stage 2 of the game, so we in fact optimize the profit functions of each firm in different scenarios. And then also we will discuss the probability of each scenario, and then having the optimal profit functions here and the probability of each scenario, we can have an expected profit function in stage 1 of the game. And then we can maximize this expected profit function with respect to quality, and we will find the equilibrium quality. And finally, substituting equilibrium qualities in the optimal outcomes in stage 2 of the game. So we have all the equilibrium solutions of this game. So let's get started with the first scenario, scenario NR. So in stage 2 of the game and scenario NR, so as I said, both firms are in the market and they make decision about their pricing strategies simultaneously. So we have this optimization problem here. So we want to maximize the profit functions of firms, both of them, and the profit functions of firms is here. You can see the formulation for that: price multiplied by the market share. And then maximizing this profit function with respect to prices. So we will have optimal or best response, the firm's best responses, right? And then we can have optimal market shares and also optimal profits. But before that, we need to know about the market share. So here in the next slide here, I want to discuss market share and how we can get market share. So we used hoteling model, which is widely used in the economics and management science literature to find the market share of each firm. So using hoteling model, we assume that all the consumers, you can see here, all the consumers are uniformly distributed on a unit line, this line, and also the market size is 1. And also each firm is located at each end of this line, right? So firm 1 is located at 0, for example, and firm 2 is located at 1. So here, for example, consumer X, which is between 0 and 1, and in this figure, for example, you can see that this consumer is closer to firm 1 or product 1. So it means that her taste is closer to product 1, right? So the consumer location is actually a metaphor for also consumer's taste. So this consumer X, the consumer which is located at X here will drive utility 1 from product 1, and utility equals V, which is the basic consumer value, the base consumer valuation of product 1, minus alpha, which is the price sensitivity of consumer, multiplied by P, price of product 1. And you can see the negative impact of price on the utility, and plus beta multiplied by Q. Beta is quality sensitivity of consumers here, minus TX. So T is transportation cost in the hoteling model. So it means that consumer X, that's her ideal point is here. So she has to travel this distance to get product 1, right? So this led to this leads to a disutility for this consumer. So minus T multiplied by X, which is this much, is utility of product 1, right? Utility that consumer drives by consuming product 1. And also in a similar approach, this consumer can drive utility 2 from consuming product 2. And here you can see 1 minus X, the location of consumer, which is this distance. So this is the distance that consumer X has to travel to get product 2. So this is the whole idea of hoteling model that we used for finding market share. But as is well known in horizontal differentiation models, so depending on the value of V, which is consumer valuation of products, so there are 3 cases for optimal prices, market shares, and also optimal profits. So, and also V here means that when V is a large value relative to T, it means that market is more competitive and vice versa. So here you can see all the 3 cases here. Case 1, which is for low value of V. Case 2, which is for intermediate value of V. And case 3, which is for high value of V. First of all, I would like to start with case 1 and case 3, low and high value of V. And then we can get to case 2. So in case 1, for low value of V, so V is less than T minus beta Q. So in this case, there are always some consumers in the middle of the market who leave the market because they drive negative utilities from both firms, both products. So you can see here between X1 and X2, all the consumers here will leave the market. And this is going to be the market share of product one, all the consumers before X1, and also all the consumers after X2 is market share M and R for product two. M and R means market share in no recall scenario because we are in stage 2 of the game, and in scenario NR. So now, and we can find these two indifferent consumers. In fact, they are indifferent between leaving. For example, this X1 is indifferent between leaving the market and purchasing product one, and X2 is indifferent between leaving and purchasing product two. So we can find these indifferent consumers that also represent for market share by setting utilities equal to 0, right? So U1 equal to 0 and U2 equal to 0. These two give us the market shares M and R1 and M and R2 here and here. So finally, we can get the optimization function here, optimization problem here for scenario NR and case 1 for a low level of consumer valuation. So as you could see here, so P multiplied by market share, and as I said, by setting utilities equal to 0, we can get market share for both products, and then we have this optimization problem. Okay, next case is case 3 actually for high level of consumer valuation when V is higher than this expression here. So in this case, market is fully covered because we assume that both utilities are positive, right? So it means that all the consumers will end up with purchasing one of the products. So product 1 or 2. But again, for finding market share, we still need to know about the indifferent consumer. Who is here, indifferent consumer is indifferent between purchasing product 1 or product 2. And this consumer never leave the market. So by setting utility 1 equal to utility 2, we can get the location of indifferent consumer, and then before this, it's going to be the market share of product 1, and after this, it's going to be market share for product 2. So you can see again here the optimization function of these two firms and optimization problems here. You can see price multiplied by market share. And this is market share formulation actually for case 3, and which is for high level of V. There is also a more interesting region for V, which is between low level and high level of consumer valuation, and we call it intermediate level of consumer valuation, when V is higher than this and lower than this expression here. So here we need to assume that utilities are not always positive. They can also be zero, right? So we can find the location of indifferent consumer by setting utilities equal to each other and also equal to zero. So because there are, so you can see here, we set both utilities to each other and also to zero. So we can get the location of indifferent consumer here. However, there are multiple set of X's here, and there are, and actually there are going to be multiple equilibria here, right? But because we are more interested in the symmetric equilibrium and symmetric firms, so we assume that firms are symmetric here, and we get the equilibrium, in fact, symmetry equilibrium here. And the market share and the optimization problem is missing here. But I can show you later. But yeah, there is a different market share, different than this case and this case. So these are actually, you can see in this slide for low level of consumer valuation. This is maximization problem here, and this is optimization problem for high level. And also imagine we know that the optimization problem for intermediate level of consumer valuation. And maximize all of these three optimization problems, so we can get all the optimal solutions in a stage 2 of the game for scenario NR. So here you can see for example, low level of consumer valuation, V. So we have P, market share, and optimal profit, which is a product of price and market share, and also for intermediate level of consumer valuation and high level of consumer valuation. And you can see all of them are different. So now we are done with scenario R. Now it's time to go through the details of scenario R. In scenario R, as you know, we have a recall, and one firm has a recall. So this firm will be removed from the market, and only one firm remains in the market. And this is the profit function of the remaining firm in the market, and the optimization problem of the remaining firm in the market here. So again, price multiplied by market share. And now, again, in a similar procedure and using the Hotelling model, we need to find market share for the remaining firm in the market. But as we discussed in the introduction and in the literature review, we know that after recall, there is a spillover impact on the product category. So based on the literature, we assume that consumers can be more quality sensitive or price sensitive, or even less quality sensitive or price sensitive after recall, right? So again, on the Hotelling line here, we can see firm 2 is removed from the market, and only firm 1 is in the market. It could be firm 2 that remains in the market, and firm 1, which is removed. However, here we assume that firm one, for simplicity, we assume that firm one remains in the market and firm two will be removed. And you can see the utility that consumer X drives from consuming product one is here. And you can see that price sensitivity and quality sensitivity here have been changed by HP and HQ. So HP is, so we call it price sensitivity change, and HQ is actually quality sensitivity change. And these two parameters, in fact, capture the spillover impact of product recall on the product category. So here for scenario R, we have two different cases. Case one, which is for low level of consumer valuation, and V should be less than here. This low level is different from case one of the scenario NR. So here, low level means V is less than or equal to 2t minus beta HQ Q. And you can see when V is low, firm one cannot cover the market. So market is not fully covered here. And also, again, by setting utility equal to 0, we can get the location of indifferent consumer, and also it represents for market share. And you can see market share for scenario R when V is low. And this is the optimization problem here. And in another in another case, case 2, we have a high level of consumer valuation. When V is higher than this expression, it means that the remaining firm in the market can cover the market, and the market share for this firm is 1. So we have this, in fact, optimization problem here. So the profit function equals to the price. In fact, the remaining firm here maximize price. So, and maximize these two profit, these two profit functions, and solving, in fact, these two optimization problems here, we have optimal solutions for 2 cases in scenario R. So you can see price for scenario R when V is low, market share, and optimal profit. And also for scenario, for case 2, for high level of V. And finally, the last scenario is scenario BR. So in this scenario, which is not complicated at all, so we assume that both firms have recall and both of them will be removed from the market. And so both don't, in fact, earn any profit here, and they do not have any decision to make. So the profit function in BR scenario equals 0 for both firms. Now we know optimal profits in stage 2 of the game for 3 different cases in scenario NR, 2 different cases for scenario R. And if we have the probability of each scenario, we will be able to find the expected profit function in stage 1 of the game, and then we can maximize this expected profit function with respect to qualities, and then find the equilibrium qualities. So here we have probability of recall for each product. So as I said in the introduction, we want to assume that firms are able to control the recall occurrence, right? So they can reduce the probability of recall by investing in quality. So for simplicity, we assume that the profit function is a function of quality, and actually it is a linear function of quality. So 1 minus QI is the probability of recall of product I. I could be 1 or 2. And having the probability of recall for each product, now we are able to find the probability of each scenario. So for scenario NR, the probability of scenario NR is product of Q's, Qi multiplied by Qj. Probability of scenario R is 1 minus Qi multiplied by 1 minus Qj multiplied by Qi. And we assume that firm J has a recall and firm I is the only firm remains in the market here. And for BR scenario, when both firms have recall, so this is the probability of this scenario. And finally, we can have the optimization problem in stage 1 of the game. So the optimization problem here is, you can see, equals the probability of scenario R multiplied by the profit of the probability of scenario NR multiplied by the optimal profit in scenario NR, and plus the probability of scenario R multiplied by the profit of scenario R minus CQ2, which is the cost of quality here. So in stage 2 of the game, we didn't have any cost. The only cost here is cost of quality, and we capture cost of quality in stage 1 of the game when they make decision about the quality. And because we have 3 cases, low, intermediate, and high for scenario NR, and 2 cases for scenario R, low and high. So there are actually 6 different optimization problems and 6 different expected profits here for intersection of each range of scenario R and each range of scenario NR and each range of scenario R. So K and S are parameters that represent for each case. And then we maximize the profit function with respect to quality. So now I want to discuss the main results here, the most important result of this study. First of all, in proposition 1, we have equilibrium qualities. So let's start with number 3. So there is no equilibrium solution when for actually low and intermediate level of consumer valuation in scenario R and high level of consumer valuation in scenario, low and intermediate for scenario NR and high for scenario R. But we have this equilibrium quality here, which is for all the cases in scenario NR and low level of consumer valuation in scenario R. And also this quality is for high value for both scenarios. So in fact, we have 4 equilibrium qualities. We have 4, in fact, equilibrium solutions for 6 optimization problems, right? So finally, you can see in this table, I think it's clear here that you can see all the price equilibrium prices and market shares for different cases. So for low level of consumer valuation scenario NR and low level for scenario R, for example, you can see prices in recall scenario and no recall scenario, and also market shares in recall scenario and no recall scenario. And also you can see for other intersections, and you can see that there is no equilibrium solutions for low level of V in NR and high level in high level in R, and also intermediate level in NR and high level in R. So now for the next result, I want to compare different prices for different scenarios, for scenario R and scenario NR. So here in proposition 2, I provided here a comparison of equilibrium prices in scenario NR and R. And you know that in scenario NR, both firms are in the market and prices are in fact competitive price. And in scenario R, there is only one firm in the market and that price is a monopoly price. So what we expect here is that price in scenario R would be higher than price in scenario NR, because firms tend to charge higher prices when they are in a monopoly position, right? So here, but this is not the case. We find a threshold for HP, or price sensitivity, changing price sensitivity of consumers after recall, when HP is sufficiently high or is higher than this threshold. So prices in competitive regime could be higher than price in monopoly regime or in scenario R. So prices in scenario NR is higher than scenario R, which is a counterintuitive insight, and it is surprising. Here, also in this slide, you can see I've done some numerical analysis for this proposition for comparison of equilibrium prices in NR and R. And I just show you 3 of them. So for low V, intermediate, and high V, when also these ranges are for scenario NR, and all of them are for low level of scenario R. So anyway, but for all the solutions, this result is the same. So you can see here that this black line is the threshold for HP. And in fact, after in the dark gray area, so when HP is higher than this threshold, price in competitive regime is higher than price in monopoly market. So price in NER scenario is higher than price in recall scenario, which is interesting. But what is the reason? In fact, the main reason is the impact of recall on pricing strategies. So when in the proposition, you can see when in fact the price sensitivity change after recall is sufficiently high, so it means that consumers are high enough price sensitive, in fact. So it means that firms charge a lower price and they choose lowering pricing strategies to capture lost consumers from the affected firm, and also for not losing market share. So everything is about market share, and they want to gain more market share here. And also, I think this is for proposition 2. But now I want to also introduce another game, which is NCR game, when firms do not consider the risk of a product recall. So we also built and solved another model, another game, which is called NCR game. And in this game, firms ignore, in fact, they ignore the risk of a product recall. And then we can have a comparison of equilibrium solutions and NCR game, and also in the original game that we had before. So I'm not gonna go through the details of the NCR game. However, I just wanted to show you the comparison of the results. So also in proposition 3, you can see we find the threshold for HQ. Here you can see we find the threshold for HQ, which is changing quality sensitivity of consumers. And we find that when quality sensitivity of changing quality sensitivity of consumers after recall is low enough, so even firms invest more in quality when they do not consider the risk of a product recall, which is also counterintuitive and surprising, because we expect that firms invest more in quality when they consider the risk of a product recall. However, here, this is not the case. And we can see that quality in NCR game is higher than quality in the regular game when they, in fact, original game, when they consider the risk of a product recall. And this is, again, the main reason of this is the impact of product recall on the product category, or more specifically, impact of product recall on quality, on change in quality sensitivity of consumers. sorry, on quality sensitivity of consumers. And so here in these figures here, you can see again, I've done a numerical analysis also for these proposition 3, and this black line is threshold for HQ. And you can see in the dark gray area, quality in NCR game is higher than quality in the original game. So it means that firms, in fact, overinvest in quality when they do not consider the risk of a product recall. And even if they, even for the light gray area here, you can see that quality in the original game is higher than quality in the NCR game. So it means that firms underinvest in quality. So both of these propositions, in fact, suggest that firms need to consider the impact, the spillover impact of the recall on product category to avoid overinvest or underinvest in quality. And also in proposition 2, to avoid overcharging or higher charging in the recall scenario after recall. So that was all I had to say here, and thank you everyone for your attention. So I would be more than happy to answer all your questions, or if there is any comments, so I would be more than happy to hear.